What's the maximum point for sine x? It's also 1. What's the minimum point for cos x? And if you see, the lowest value is -1. And the minimum point for sine x is also -1. So very simple similarities. What about the period? What's the period? How long does it take for a cycle to repeat? I know the period for sine x, I already told you, was 360 degrees. What about the period for cos x? Well, cos x, we start off at a point very high, at our maximum point. Then we go down, and then we hit our middle point, center line. Then we go down, now we hit our minimum point. Now we're going back up, and now we're back to our center line. Now, what was our starting point? Was our starting point the center line? It was not. Our starting point was the maximum point. So we got to keep going all the way back to the maximum point, and now at this point, we've completed one cycle. And you can see that the period also, in this example, is, or for this function, I should say, is 360 degrees. So sine x and cos x share the same period, share the same maximum point, share the same minimum point, and they even share the same center line. And what do I mean by center line? I mean the line that's exactly in the middle of these functions. So yeah, what do I call this? Do I call it a center line? I forget. Center of axis? Midline? Forget the name, but I'm pretty sure it's all of these names. Center line, center of axis, midline, whatever you want to call it. It's kind of the middle line. All right. So we have our midline, we have our maximum, minimum, we have our period. I think that is pretty much eight. The only difference between the two essentially is just their starting points. They even share the same points. What do I mean by share the same points? I mean like the maximum, minimum points and the middle points. They share those points, but they share them at different times or different x values. That's essentially what's happening. So the difference between these two graphs is actually just a phase shift. If I were to take y equals sine x and just move it to the left by 90 degrees, this point here would shift this way, this point here would shift this way, this point would shift this way, this point would shift this way, and the other point would shift this way. And you'll see that in green, I have my cos x function. It's just a phase shift, a shift of left or right. That's the only difference between these two functions. And that's going to come into play a little bit later when I hopefully get a chance to show you that. So here are domain and range. Oh, that's important. So domain and range is also the same for both of these functions. Domain is XCR because the function goes all the way to the left and all the way to the right. The range, however, is limited, is restricted between -1 and +1 because the maximum point and minimum point. Period is 360 and amplitude. What is amplitude? That is also similar, the similarities between these two. In the definition of amplitude, there's two definitions, you could say. It's essentially the distance from the center line to the maximum point, or the distance from the center line to the minimum point. So that is the definition of amplitude. Forget the exact definition in words. It was something to do with like the maximum perturbance or disturbance or something like that when it comes to a wave. I forget now. All you need to know in terms of math, it's the distance, the y value distance between the maximum point and the center line, or the y value distance from the minimum point and the center line. Because these are symmetrical, if you haven't noticed. There's symmetry here. So yeah, the other thing that makes finding amplitude very easy is an equation, and the equation is max minus min divided by 2. That is your equation for amplitude. Let me see if I did that right. Yes, max minus min divided by 2. Definitely write this down. There's a few equations that I'm going to tell you. Please write it down, make a cheat sheet, do something, figure it out. Now we're going to talk about transformations. Transformations. times a what? All right. So just like our previous lessons on transformations, we have our, transformation values, the usual suspects, A value, which is a vertical stretch or compression, K value, which is a horizontal stretch or compression, D value, which is a phase shift left or right, and C value, phase shift up or down. And remember, A and K also have a reflection if they're negative. So the usual suspects. Let's do some examples. Oh, yes, a few equations that I should mention. Your A value is equal to your amplitude. So A for amplitude. Now, don't forget this vertical line here. What that means is absolute value. Absolute value just means that any number inside these vertical lines always spits out the positive answer. So -5, absolute value of -5 is 5. Absolute value of 5 is also 5. So don't think that you're flipping the negative sign. That's not what absolute value is. It basically takes what's called the magnitude or the numerical value, irrespective of the sign. So you don't care if it's positive or negative. The absolute value is just the magnitude, it's just the value, it's just the number value, the positive number value. So amplitude is just the absolute value of A. Your period is equal to 360 divided by the absolute value of K. So whatever your period is, your K, and you can swap this around if you know a little bit of algebra. Your K value is just basically 360 divided by period. So this is a very nice equation. So if I know my K value, I can figure out my period. If I know my period, I can figure out my K value. Simple. And D and C are usually pretty easy. Actually, for this unit, D is very hard. C is very easy, but D is very hard. D is the most difficult one for this unit. So let's do an example here. Very basic example. So in this example here, we need to label our transformation values. What are our transformation values? Well, I know A value is equal to 3. It's the first, number in front. Now, see all these brackets? That's good. We want to see those brackets. So the K value is inside the bracket. The D value is, the value inside the bracket that's adding or subtracting your unknown value. And in this case, instead of using X, now just so you know, we can use X. But when we're working with angles, usually we use the symbol theta. But you can also use X because it's just an unknown value. It doesn't really matter. We can use almost any symbol. But yeah, normally we like to use theta for angles. So my D value, is my D value 60? What do you guys think? Is my D value 60? Yes or no? I'm not going to wait that long. So just answer to yourselves. If you can answer in the chat, go for it. Is my D value 60? Yes or no? Looking for a yes or no answer. Yes, it's 60. No, it's not 60. Let's see, we got someone answering. And unfortunately, Tal and Elizabeth, are you positive? Tanzid, are you 100% sure? Am I trolling you? Maybe. D value is not 60. Shocked Pikachu face. What is my D value? It is -60, yes. Just remember that. Remember that small little thing, all right, guys? So D value is always the opposite sign of what's in. Yeah, I know it's been a while. That's why I asked. So now, hopefully, you won't forget. Because remember, you always learn more from a mistake than if you were to get everything perfect. So now you'll be like, oh yeah, I got that wrong. I'll remember that. Those emotions, you'll be like, oh, Mr. Khan tricked me. But now you'll remember. Now you'll always remember that D value is -60. Anyways. Okay. So first things first. Let's type out what this means. Vertical stretch by a factor of 3. That's my A value. Horizontal. Now is it horizontal stretch or compression?